Good afternoon, my beloved colleagues. Now, in second video, we will discuss about the application of Faraday's law as well as Lenge's law. Now, in first application, we will discuss motional electromotive force. There is motional Now, in motional electromotive force, there is also the EMF will be generated. But here, the EMF will generate due to motion of the conductor. Now, first we will draw the figure. For example, there is one conducting loop is present, magnetic field is present here. There is the magnetic field is present. Now the magnetic field is B. Now here I kept one conducting loop. Now at any instant there is the distance is x and that it is L and the velocity of the conductor is V. Now the conductor is moving in that direction. Now EMF will be generated. What will be the EMF? Now flux phi, when we discuss about the flux phi, is equal to B into A. Now B, there is area. There is area is present, L, and that is the X. So Lx. Now induced EMF E is equal to d phi by dt. There will be minus. Now minus d dt of, there will be BLX. Now there is BL coming, there is the, and dx by dt. Now the dx by dt, that will be the minus. So that will be BLB. Now minus dx by dt, that means the area is decreasing in the direction that is the decreasing. So induced EMF, that EMF E is generated. E is motional EMF. Now motional EMF is equal to BLB. That is the EMF is generated in the conductor. Now, what will be the current? The current, if the resistance of the conductor is R, if the resistance of the conductor is R, then if the resistance of the conductor is R, then what will be? Then current. The current I is equal to E by R. So there will be BLV by R. That is the current. Now the force on the conductor, F is equal to ILB. Now I is the force. The value of I will be the value of I is BLV into L into B into IBLV LB by R. So that is equal to B square L square V by R. So that is the force is generated. The force is generated due to motional EMF. Now power P is equal to F into V. Now F into V, so there will be F B square L square V into V by R. So there will be P square L square V square by R. So that power will be generated due to motional electromotive force. Next point. Next we will discuss eddy current. Next we will discuss eddy current. Now what is eddy current? What is eddy current? First we will write down eddy current. What is eddy current? We will see that. Now the second application we will discuss eddy current. Now what is eddy current? Current CU or
Start.
now eddy currents. Now what is eddy currents? Eddy currents. Basically the current is produced due to changing magnetic field. Now the changing magnetic field in nearby metal body that will produce eddy current. For example, there is one magnet is present and there so in that plate there eddy current will be produced. Now changing that is the one plate is present, the plate is moving, so there is magnetic field is present, so magnetic field is also changed. As the magnetic field is changed, so there will be one current will be generated in the plate and name of that current is eddy current. So changing magnetic field so changing magnetic field set up current nearby metal plate. That current is eddy current. Now, the eddy current is undesirable. It is not required. But what is it will only produce it. It is produce it. How to minimize the eddy current? Eddy current can be minimized by using the lacquer or varnish. When we will use the varnish, there will be good insulator is required to use, and with that the eddy current will be minimized. Not only that, there is also possible to minimize the eddy current with the help of reduce the area of the plate. For example, if we take that area, if we take that plate, there is the one plate we take, but if we take the strip, there is the one area is decreased. Next, there is another strip we will take. So there that part is not present, that part is not present. So in that way, so there is the small, so net eddy current will be decreased as the area of the plate is decreased. Now application of the eddy current. What is the application of the eddy current? Application of eddy current. Applications of eddy currents. 1. magnetic braking of train. Two. One is magnetic braking of the train. That is the application. Second is electromagnetic damping. Electromagnetic damping. What is electromagnetic damping? With the help of eddy current, we can reduce or galvanometer comes to its original position with the electromagnetic damping. Next is electric furnace. Electric induction. Induction furnace. Electric induction furnace. So, induction furnace, that is also based on eddy current. So, that is the all about the eddy current. Now, next topic is induction.
But
Now we start inductance. 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 There is two type of inductance. One is self-inductance. Self-inductance. And another is mutual inductance. Inductance. Now, what is self-inductance? What is self-inductance? Self-inductance means the induced EMF is produced in its own coil. अपना coil में हुआ है. The induced EMF is produced in its own coil. So how it will be? First we will see that. There is the one figure I want to draw. Just see. There is one cell is present. Now, here one coil is present. And one here tap key is present. Now when key is closed, it is closed. Now current is in that direction. Now the induced EMF will be in that direction. Induced current, induced EMF will be in that direction. Now similarly, if now the figure is that if key is open, just see, when it will close, the induced EMF is opposite to the direction of the battery current. Now when it is open, induced EMF or induced current will be the direction of the same direction of the battery current. Now induced EMF. Now what is the cause of the production of induced EMF? The change of flux. The flux, the amount of flux produced in that is directly proportional to I. Therefore, in that case, phi directly proportional to I. Now phi is directly proportional to phi is equal to L into I. Phi is equal to Li. Now L is self-inductance. Now induced EMF E is equal to minus d phi by dt. We know that. So therefore minus d dt of L into I. So So here will be minus L di by dt. So that will be the another form of self-inductance. Now, the self-inductance for long solenoid, we know that, and that value will be mu 0 n square Al. So that will be the value of the self-inductance of the long solenoid. Now self-inductance is called the back EMF because as it opposes the production of the current in the cell. Now it is the inertia of the cell. Self-inductance is also another name is inertia of the cell. Why it is called the inertia of the cell? It is analogous to the mass. As mass opposes the inertia, similarly in any circuit, self-inductance also oppose if any change happen in the circuit. So for that reason, self-inductance is called inertia of the circuit. Self-inductance is called the inertia of the circuit. Now what amount of energy is stored? What is the use of the inductance? Now in capacitor, the electrical energy is stored, and in inductor, the magnetic energy is stored. Now value of the magnetic energy is in self-inductance magnetic energy stored in inductance is equal to half Li square, and that energy is stored as the magnetic energy. So that is the energy stored in self-inductance is half L square. That is all about the self-inductance. Now we will discuss mutual inductance. Mutual, that means there is two coils present. Now first we will see the figure. For example, now there is two coils present. That is the primary coil and that is the secondary coil. Now current is passing through the primary coil. Now when the current is passing through the primary coil, the flux will be changed. As the flux will be changed, the magnetic field also will be changed. As the magnetic field is changed, the induced current will be generated in the secondary coil. As the induced current is generated in the secondary coil, galvanometer show deflection. So mutual, that means current is passing through another coil and EMF is generated in another coil. So here amount of flux in secondary coil phi is directly proportional to I, but here I is equal to IP. That means due to primary, current is passing through the primary. So I, so flux directly proportional to I. So flux is equal to MI. M is called coefficient coefficient of mutual inductance. Now we are already know what will be the value of that. The two coaxial coil will take, and is their number of turns is different, the radius of the coil is different. If one is current passing through that coil, so what amount of magnetic induction M will be produced in another coil, we already know that thing. So everyone is familiar with that, so not required to discuss about that. So all about everyone understand the basic idea. So what is mutual inductance? So mutual inductance, when the current is passing through the primary, there in secondary there will be induced EMF will be generated. That is the mutual inductance. Now the last topic of whole chapter of electromagnetic induction is an ultimate use. It is the use of the mankind, and without electromagnetic induction it is not possible to produce the generation of current. And there is the one application is present, AC generator. Now AC generator. Now AC generator, it is based on electromagnetic induction. Now in AC generator, what is happening? Mechanical energy convert into electrical energy. Now in AC generator, there is two magnets present and there is one armature or coil armature is present. Now in armature, when the armature is rotating, there will be the magnetic field will be changed, and magnetic field is present and the flux also will be changed as the armature is rotated high speed, and there will be the induced EMF will be generated. And in that in AC generator, E is equal to E0 sine omega t. Now that is the in AC generator, that will be the ultimate production of the EMF, and that is the induced EMF. E is equal to E0 sine omega t. And frequency in India, the frequency is 50 Hertz. Now, in that there will be the one sine curve will be happen. So everyone see that sine curve, how the sine curve will be. So that is the 0, 90, that is 180, 270, and there will be 360. Now in the first case, what will, for example, there is the magnet is present. Now there the armature will be, in that cases the armature will be perpendicular to the magnetic field. In that case, perpendicular, armature will be perpendicular. In that cases, armature will be parallel to the magnetic field. Here will be perpendicular, here will be parallel. Again, in that cases, there will be perpendicular. In that cases, there will be parallel, and in that cases, there will be perpendicular. So that is the very important things. The magnetic field and the armature, the plane, and that will be perpendicular. So that is the very important case. We are all know that about the AC generator, how it will be produced. We already will be familiar with that. So basically, and the sine curve will be happen. So how it will be, and there is the one thing that is present, the how the armature of the coil and the magnetic field will be. That is the very important topic, and that is the how the production of the will happen. There basically there is when we will discuss about that, the flux phi is equal to BA cos theta. There will be BA cos theta. Now B is not possible to change because the magnet is fixed. Area is not possible to change. So there is only one thing is changed, that is BA cos theta. Theta angle is also will be same, but theta is equal to omega t. Why we use omega? Now the rotation, omega, high speed, there will be rotation by changing rotation. If rotation is increased, so there will be flux also will be changed. So d phi by dt. So that will be E into the EMF E is equal to d phi by dt. So there will be your, so BA will become BA omega sine omega t. That will be E is equal to minus, and there will be minus one the plus. So if n number of strands is present, so there will be n will become, if n is present, n d phi by dt. So that will be, and that part, that is equal to E0 sine omega t. So that is very important topic related with that, with our physics AC generator, and that is the ultimate outcome of that electromagnetic induction chapter. Thank you. Have a nice day.